I can see that you all believe this. That's reassuring to know what you think of me. Yeah, yeah, it's like, yeah, that sounds like a thing Stephen would do, alright. I would. I wouldn't think twice about it. Alright, now let's do this juicy, delicious question. Sean? Sean?
Yeah.
Could you wake Jerry up, please?
We go. Hello. We can't. Thank you.
Nice. Okay. Sleepy Jerry?
What?
Tired?
Yeah.
Tired.
Maybe possible.
Sunshine.
That.
Oh, okay. 3-point charges A, B, and C. 4, 2, 2. The circle's radius is 4.33 10 to the minus 2, so that's 4.33 centimeters. What is the electric field strength at the center of the circle due to the 4? Due to the 4. Okay, so forget about the 2 and the 2, just the 4 first. Okay, so here is the circle. Here is the 4 microcoulomb, and here is the center. And this distance here, you know it. It is 4.33 times 10 to the minus 2 meters. So the formula for the electric field strength here, now the electric field goes from positive to negative, so the field is actually pointing down here. That will be E equals, oh, what is this now? This is Q over 4 pi epsilon 0 or squared, isn't it? Yeah. And the Q is this, and the or is this. So if I just take out my calculator, sorry Monica, what number, or, well, whoever knows, what number is epsilon 0? 32. And the radius is 0.0433. And this is 4 micro. Like this. So the electric field strength is that much. 1.917 10 to the 7 Newton, that's a 7 newtons per meter, and that's heading down. Newton per coulomb, sorry, Newton per coulomb. Now, part 2 is what is the electric field strength at the center when you consider all the charges. So, there'll be one, we've actually nicely enough worked out one of these. Now, in fact, in the exam, what I've noticed is sometimes they don't even ask you to work out one of them. They might just say, what is the total? So they've actually broken this into 2 parts, which is good because it means you can get more marks this way actually. So consider this one right here and this one right here. That one will have a field this way and that one will have a field this way. Okay? Now, we can actually, if we're really, really smart here, we can take a bit of a shortcut. Okay? Is the distance the same? Yeah, the distance. Firstly, let's look at this one. Right. Is the distance the same as the last one we did? It is. Is the charge the same? It's nearly the same. It's only half. And because the Q is on the top, it means if I make the Q half as small, then the strength is half as small. So just to make this easy, I'll call this result here E1. This is E1. That means this one here is E1 over 2. And this one here, E1 over 2. Now, is that okay? Now, what I'm going to do next is I'm going to resolve. So this has a component to the left, and this one has a component up. And this one has a component up, and this one has a component to the right. Now, we need to work out this angle. So if I draw here, how much is this angle? That is 60. Because the total is 180, and they said that this is 120, so this is 60. So how much is this? 30. 30. So this one here, is it 60? You could do, hang on. This one here is 30, which means this one here is 30. That's 30, and this is 30. No, I did that wrong. It's getting a bit messy. Let me just draw it on the side. Okay, look. Piece. That's 120, 120, 120. Okay, so this one here, for example, has one this way and has one this way. Right, that's 120. That's 60, because this is 180. So that means that has to be 30. And it's the same on the left and the right. So here, this one here has to be 30 as well. Okay, so that's fine. So that means this is 30 and this is 30. Now because this is 30 and this is 30 and this is the same and this is the same, it means this component and this component will cancel. So we have two going up and one going down. So the ones going up will be E1 over 2 sine 30 plus E1 over 2 sine 30, which is sine, it's just E1 sine 30. And the one going down is, we just said, E1. So which is bigger, up or down? Down. So the total is E down will be E1 minus E1 sine 30, which will be 1 minus sine 30 E1. So in other words, that answer, the answer we got from part 1, multiply that by 1 minus sine 30, and we have the answer. So 1 minus sine 30 times 1.917 times 10 to the power of 7. Yeah? 9.59 10 to the 6. 9.59 times 10 to the 6 newtons per coulomb
Upwards.
downwards.
No, you make it straight.
Do I have it backwards?
Yeah.
No, I'm right. Down is bigger than up.
No, up is bigger than down.
Oh, you're looking at it backwards, yeah. The 4 on the top causes a downward feel at the centre.
Why?
Because it's positive. Positive is outwards. Remember the electric field diagrams we drew?
But they push each other away. I mean, they are all positive. I thought they all move, outward.
I understand. The electric field vectors are like force vectors. So they add the same way. So if we have one pointing down because of the one at the top, and one's pointing up because the one's at the bottom, we just add them together like as if they were forces. I'm a bit confused, not that you're confused, but I'm just confused about what is confusing you. Like, what's your question, so I can help?
We say that the positive going outward from the point, but it can be going up to instead of going down. Because it's spread outward, rather than necessarily to be down instead of up. The thing is, why is it moving towards the center?
It's not. Those aren't forces or directions, that's just the field. The field is moving towards the centre because the field emanates out from the 4. So if you imagine you're standing in the centre there, which way would you feel the field? pointing down. If you were a positive charge in the centre of that circle, which way would you move?
Down.
Yeah. Away from the 4.
Yeah, away from the 4.
Yeah.
Which the 4 is, I think...
Down. Yeah? Yeah.
Yeah.
It's okay? This is a very hard question. Now it's 7 marks, which is a lot.
Yeah, 7 marks.
But that doesn't mean it's...
7.
Yeah. Yeah. Now, I was able to take shortcuts. I was able to take shortcuts because the 2 and the 2 are the same, and the 2 is half of the 4, and it's the same on the left and the right. Okay, sometimes they don't do that. I've seen one question, in fact, maybe I have it here, if I saved it. No, I don't have it. I don't have it, but I'll draw you a picture. I've seen one question like this, where they have a 1 micro, a 2 micro, a 3 micro, and a 4 micro.
Oh, yeah.
And they want the strength here. So this one here causes a field this way. This one here causes a field this way. It'd be a bigger field. This one here causes a bigger field, and this one here causes a bigger field. And you have to add these together. So if you think about it, this one will subtract from this one, leaving you with a little bit this way. And this one will subtract from this one, leaving you with a little bit this way.
Oh.
So you're probably left with a field like this. Are you okay there, Monica? You're giving us all heart attacks here. Okay. Anyways, very hard question. The bad news for you is the person who's writing the exam and the last person. I think they like this question. Yeah, so be prepared to see it. Anyways, do you need to write this down? We only have 3 weeks left. Did you know this?
So sad.
No, it's
Yeah,
3. 3 teaching weeks.
3.5.
3.5.
Because the exam is Thursday start.
Oh, okay, but I don't know if there'll be classes. I don't know if there'll be classes that week.
I don't know.
I will forget you, yeah.
1 week gap to study physics, right?
I think so. No, I will forget you.
Wow, come on, dude.
If my relative comes today,
I have friends coming over.
Do you have any more family members that I could see?
Her
I
sister.
don't know,
Maybe.
Maybe.
I don't know.
If I was to see your sister, how many years in the future would that be?
Oh no, I don't have a sister.
Another brother?
Probably.
Best till last or worst till last? So I should keep an eye out for a future family relative? No, okay. Yeah, I won't, don't blame me. Alright, let's close this one now. That was very hard